This is your lesson on Hess's law. Okay. Let's look at this reaction right here. You have N2 plus O2 becoming NO2. And we want to try to find the delta H of this chemical reaction, RXN. So when we went to the lab, we mixed N2 and O2 right here. And unfortunately, we only got NO, not NO2. And we used up this much heat. This is endothermic. It's positive. So we said, oh, we're going to go back to the lab and turn the NO and mix it with some more O2. And then finally, we got the NO2. So what happened is, since this reaction happened in 2 steps, Hess's law states that all we can do is we can add the delta H of reactions of these 2. So because these 2 equations, equation number 1 and equation number 2, was used to get to the final equation, we can just add these delta H's, okay? The reason we can do that is because energy, or delta H, is a state function. If we wanted to mix N2 and O2, and we wanted to turn that into NO2 right here, N2 plus O2 makes NO2, and if it happened in step number 1, and it happened using another step, 2 steps, all we have to do is add those 2 delta H's, delta H, and we're going to end up with a delta H of this total reaction. Okay, so let me just define it for you first. Hess's law states that if a reaction happens in more than 1 step, then all you have to do is just add the heat of reactions. Here is the formal definition. The enthalpy change of an overall process, in this case, it would be, this is the overall process right here, is the sum of the enthalpy, so you add them up, the sum of the enthalpy changes of the individual steps. So here are the individual steps 1 and 2, and all you have to do is add these up. But before you add those up, we have to follow some rules. Let me show you some rules. Okay, the rules state that if you reverse this reaction, you have to change the sign. So it'll be negative 68 kilojoules. And if you double the reaction, let's say we double everything, then you're going to have to multiply 68 times 2. You have to double the delta H as well. Okay, let's do this problem. So I'm going to go ahead and I'm going to keep my eyes on this final equation here. This is me looking at it. Okay, keep your eyes on this. I'm going to look at equation number 1, and I'm going to rewrite it. Okay, equation number 1, I see N2 and O2 are both on the left side, and NO is nowhere to be found. So I want these 2 on the left side, so I'm just going to copy the reaction. N2 plus O2, arrow 2NO. Since I did not reverse it, I'm going to use the 180 kilojoules. Okay, now let's look at equation number 2. For equation number 2, it looks like NO2 needs to be on the right side of the equation. So that means I'm just going to copy this the way it is as well. 2NO plus O2 is 2NO2, which is negative 112 kilojoules. Okay. If these 2 reactions add up and it looks like this overall reaction, therefore I can add the heats of reaction right here. So let's see if it adds up. And the way you add it up is you cancel anything that appears on both sides. You see how this 2NO is on the right side and the left side? Those 2 cancel, and nothing else cancels. Then you just copy everything on this side down here. So I'm going to copy N2 plus O2, and there are 2 of them, so I'm going to put 2 right there in the front. Arrow, and I'm going to copy this on the right side, 2NO2. Now, does this overall equation look like this. It looks exactly like it. Therefore, I can just add these two numbers. So when you add those two numbers, since it's a negative, I actually subtract. I'm going to get 68 kilojoules. And that is the answer for the heat of this chemical reaction in kilojoules. Okay, let's try another problem. Okay, here's another problem. It says that the overall reaction looks like this. So you keep your eyes on that. I'm going to put my face. That's me looking at it. Keep your eyes on that. Look at the first equation. The S is on the left side. The O2 is on the left side. SO3 is nowhere to be found. So I'm just going to put these on the left side of the equation. I'm just going to recopy it. S plus 3/2 O2 SO3. Okay, and I'm going to rewrite this number. Negative 395.2 kilojoules. Okay, now looking at the second equation. Do you notice how this SO2 needs to be on the right side, on the product side? What I'm going to do is I'm going to put these on the right side. I'm going to reverse this reaction. So I'm going to put the reactants in the product side, 2SO2 plus O2, and I'm going to put the product in the reactant side, 2SO3. I just flipped them. Since I reversed the reaction, I get to reverse the sign of this. Positive 198.2 kilojoules. Okay, that's the first step. Then I get to add them together. Make sure that it looks like this overall reaction. All right, so it looks like I can cancel the SO3 here, but I can only cancel one of them because I have two here and one here. And if I look at the overall reaction, I should not have any. So I'm going to do a little trick. What do you think I should do? So all of it cancels because I don't want any SO3s in there. Yeah, I think I'm going to multiply the whole top by 2. If I multiply this by 2, I multiply this by 2, I multiply this by 2, therefore I have to multiply this by 2. Okay, now it cancels. There you go. Okay, then this 6 divided by 2 is 3. It's just like canceling the 2's cancels with this 2. So I have 3 O2's here. I have 1 here. So that means, let's use a different color, pink. That means I have 3 here. I have 1 here. This goes away, and I'm going to have how many left? I'm going to have 2 left because one of them got canceled. Okay, so now is there anything else I can cancel? The 2s can't cancel with this. Okay, so nothing else cancels. I'm going to then write this that did not cancel down here plus 2O2 down here, arrow, 2SO2 plus, oh no, that's it. Okay, so if I look at the final equation and it doesn't look like this, oh, it kind of looks like it, but do you see how it's doubled? So what I will do is I will divide the whole thing by 2. And that will do it. So what I do is I'm going to add this up. I'm going to get a number. And whatever number I get, I'm going to divide it by 2. Okay, so I'm going to add this up. And when I do that, I'm going to get negative 592.2. 592.2 kilojoules. And the final answer, divided that by 2, and the final answer is negative 296.1 kilojoules. So the answer for this overall equation or reaction is negative 296.1. Negative 296.1 kilojoules. Okay, please pause the video and try this one yourself. Okay, so it says 2 gaseous pollutants that form an auto exhaust are CO, carbon monoxide and nitrogen monoxide. Okay, so these two right here, and it becomes these two products. They're looking for the delta H of the reaction. It says, given the following information, calculate the unknown delta H. They want to know this right here. And these two equations, if I can add up equation A and B to become this one, then I can add up the delta H's as well. Looking at equation A, do I reverse or not reverse? I see that CO is on the left side and CO2 is on the right side, so I'm going to not reverse. Arrow, write this down here. CO plus 1/2 O2 is CO2. Negative 283.0 kilojoules. Okay. Also, go ahead and line up the arrows. It's easier for you to see what one cancels. Looking at the second equation, it looks like N2 should be on the right side. So I'm going to reverse the second equation. Put the N2 on the right side, and then the 2NO on the left side. So since I reversed it, the sign of this becomes negative 180.6 kilojoules. Okay. Next thing I do is I add these up, making sure that it adds up to the overall reaction. Let's see, what can I cancel? I don't have any O2, so I think I will go ahead and I see a 1/2 there. So I think I will go ahead and double the top to cancel all the O2s. Let's see if that works. Okay, I'm going to double this, double this, double, and double the kilojoules, the delta H, which means 2 divided by 2 equals 1, which means 1 O2 cancels with 1 O2. Does anything else cancel? Nope. So I'm going to go ahead and drop everything. 2CO plus 2NO, arrow, 2CO2 plus N2. And I'm going to go ahead and add these up. And when I added them up, I'm going to get a number. Okay. But I see that this equation is double the overall equation, which means whatever I get, I'm going to have to divide it by 2. Because I have to divide this whole thing by 2 to make it look like that. Okay, so the overall action, when I plugged it all in my calculator, I got negative 373.3 kilojoules. And that is the heat of reaction for the overall equation.